Hello, everyone. Welcome back to Creation Myths. I am so excited to be here tonight. I have been looking forward to this for literally months because tonight, earlier this evening, was the debate between Dr. Zach Hancock and Paul Price on the topic of, the topic was like, are mutations a problem for evolution? But it was about genetic entropy. It was a debate about
It was
genetic
very
entropy.
quick, like immediately we were genetic entropy. Yeah.
So I am just looking on YouTube. I hear myself. I see myself. Everything seems okay. Folks, if you watch the debate and want to talk about the debate, the link is pinned over in the side chat. So help yourself. I'm giving priority to people who, first priority is to people who participated in the debate, and then people who watch the debate, and then anybody else who wants to talk about stuff is how we're going to do it. So, chat, you know the deal. Just let me know if the audio or the visual is weird. Folks in the green room, you're hearing me twice because you are hearing me on YouTube and via StreamYard. So mute your YouTube and you will be fine. That's why you're hearing me twice. Okay, so Zach, what do you think? I want to hear your quick take on the debate. Immediate, reporter in your face while you're
Yeah.
still on the field. What did you think of the game?
Yeah, these things never go the way you think they're going to, or the way you kind of prepare them to. The topic of the debate was, are mutations a problem for evolution? This is basically a debate about genetic entropy. And what I sort of went into the debate thinking is I didn't want it to end up being all about parameters of models. You know what I'm saying? I really didn't want that to happen. What I wanted to talk about was comparing predictions of genetic entropy versus those
Right.
of selection, of Darwinism, if you will. So
Which your opening was structured that way.
and that's the way that I try. It's like comparing these two predictions. Let's see if we can distinguish them. And do we have a model that can distinguish them and actually make predictions in the real world? Because we could talk all day, we can debate all day about model parameters, right? Should you parameter this way like this or this like this? And you can simulate all kinds of things. But to me, the more powerful argument was to make something with a model with biological data, right? So that's the reason I went the way that I did. And I don't feel like Paul understood it enough to ever actually respond to it. And
Yes.
so I kept trying to bring it up and he kept moving away.
Not right.
And so I don't actually know if I made the point as clearly as I would have liked to, basically because of that.
I will say that as someone now, I am biased in two ways. One, obviously, we do very similar things on the internet. We have collaborated on things on and off the internet. So, like, obviously, I'm biased here. Also, I come into this as someone in the same field as you. So, as soon as you started going down this road, I could see how you were structuring it and exactly where you were going. And there was a funny thing where there was somebody in the side chat, like, maybe 3 or 4 minutes into your opening who was like, well, I see Zach is just going with assumptions without any data to back him up. That's disappointing. It was like, well, so he's setting up the dichotomy.
Let me cook.
Like, let's give it more than 3 minutes. He's setting up the dichotomy, and then we're going to show what the real world looks like and assess which one of those options is correct based on the action, right? So I thought that was very clear, but again, I saw where I could see what you were doing because I
because
know
what
the
you
field
often
and know the
find,
structure.
you often find in these things is that we debate models. So we debate Kondrashov, we debate mutation load paradox from Haldane, we debate Sanford's models. None of those things are ever applied to actual data, and none of those things have ever made predictions about nature that have ever been verified, right? That you've actually ever been able to go out and make predictions in nature. Whereas the infinitesimal has, and it works really well. And so to me, we should be working off of models that do that, as opposed to debating, what's the shape of distributions and that sort of thing.
Yeah, just try to like match reality. What gets you closer to matching reality? And I love the agriculture aspect of it. Like, you can disagree with this model, but this is how we select for things that we eat. So it's hard to dispute like what actually exists in the supermarket and how we got there.
Yeah, if even things as simple as the amount of oil in a corn kernel, right, is determined by thousands of alleles. all across the chromosomes, most of which have teeny tiny effects. And yet we see strong and consistent directional response to selection.
Right.
And we also see that in things like Darwin's finches, like the beaks are determined by hundreds of genes. And yet we see strong and consistent responses in a way that we can predict. And that's completely opposite of what genetic entropy would say, that all of these tiny alleles should be under selection's purview or should be invisible to selection, and it can't actually overcome them. And that's just not what we see at all.
And,
so
right, in the real world, things do not behave in the way that genetic entropy dictates they must behave when we watch them change over time. Yeah. And I want to, before I start bringing in other people here who are in the green room, I want to everyone to appreciate something that you did in your cross-examination right away. Because the point kind of Paul was making, and doing this kind of argument via quotation thing that's kind of very Sal Cordova-esque, like this guy said this guy said that, and it was really fun in chat playing the game of which author is he going to cite next.
Yeah.
And
Lots of Lynch.
so it was Kondrashov and Lynch and San Juan and Kitely and Airwalker. It was like, it was in all the hits. And but you instead of kind of digging into all those, just said, like, here are 3 graphs. There's strictly neutral, slightly beneficial, slightly deleterious. According to genetic entropy, they should all behave the same way. Mm-hmm. And these 3 graphs are different. Can you tell me which one is which? And it was clear looking at them, like, boom, 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 which one was which, just based on the trajectories of the alleles that were being modeled. And that was, within your rebuttal, that was 5. So Paul had his opening, that was about 15 minutes. Then you had your rebuttal. It was in that 5-minute rebuttal. And like, that was it, because if selection can distinguish between those things, then that's the end.
And that's like, I was surprised at how quickly he actually agreed to that.
Yeah.
Like, I thought I was going to have to fight him on it. And he was like, no, that's selection. And I was like, well, so then do you agree that far fewer beneficial mutations compensate? And he's like, yeah.
Yeah.
That's,
okay.
That's the whole thing.
Thanks. Yeah, it was. Well, I think, and you said at the very end, you complimented Paul, said, you dug into this, you learned how to use Slim, like, power to you, because most people, literally nobody except Paul, has like done that.
No professional creationist
right.
actually tried to do this. So
right.
Respect to Paul for that.
Yeah, no, Paul, I put him during the debate for actually doing all this. I put him on my list for the Cambrian Bunnies nominations for next year, because like, he actually learned how to do this.
He learned,
and power to him.
He clearly put in a ton of work for it. I just want to be sure that we kudos Paul for the amount of work he put in to be able to learn how to do those simulations.
But that being said, but he clearly did still not understand the underlying population genetics, because the thing with the 3 graphs that you did was the end of the debate. Like, to be clear for everyone, that was the end of the debate, because the fundamental premise of genetic entropy is that those 3 classes of alleles are the same in terms of how they can evolve. And
unless no selection zone means something other than no selection zone.
That was part of the argument, wasn't it? The no selection zone was actually sometimes maybe not as much, but still, right. It was if we reinterpret Sanford to mean something other than what Sanford wrote, and then subsequently confirmed in writing multiple times, and then also said out loud, then you could torture it into meaning something that approximates.
And I also want to make clear the point, and I'm not sure if I made this super clear in the debate, was that if a trait is determined by lots of genes, then individual genes no longer have fitness effects, right? Their effects are solely based on the phenotype. So the concept of an effectively neutral or slightly, that doesn't actually make any sense, because lots of combinations of allelic effects will give you the same phenotype, right? Yes. In fact, that's how genetic variance is often maintained in populations, is because recombination shuffles things around, and all the best possible combinations ends up sticking around. Yeah. And so like, in that context, and that's why I tried to make clear that why this idea completely nullifies Kondrashov's paper is that if you view traits as polygenic, as not as one gene, one phenotype, which is what's required to put a fitness effect on a trait, if you think about many genes to a trait, then it's just the genetic variance, which is really small in all populations, and selection is really good at weeding it out.
Yeah. So those are, I think, our kind of top line thoughts, immediate aftermath. So I want to cover a couple super chats here. Then I'm going to bring some people in. So first, Scott Duke for $9.99. Thank you, Scott. I don't have the knowledge to contribute. So how about a cash contribution? That is very generous, Scott, but also you would be welcome to join. You should click that link and join because it's always a pleasure. And then Sydney Raptor for, is that $5 Australian, or as I think we're supposed to call them, dollary dues, I think is the proper word there. Psst, whispers, I'm curious, what did you guys hide in your supplementals? And have you gotten away with it so far? Don't worry, we won't tell anyone.
I don't think we actually had any supplementals. So our supplementals,
no.
Our supplementals are just the GitHub page,
yeah,
which you can just see basically the code that we run.
Yeah, there weren't the 70 pages of data that you find in other papers where they hide the actual groundbreaking findings.
Right, we didn't do an empirical study, right? It was just basically.
Yeah, that's all. All right, so I am going to bring in some friends here. So we've got Nestlig is here, and Andrew is here, and I don't know Eloy, but Eloy is here. Welcome. So let me start. Oh, but actually, before we go any further, I should just say I do not pay for StreamYard, so I can fit, in addition to me, 5 people total. So if people want to come and go, we can rotate. It's cool. But just be aware of that, folks. I'm not paying whatever StreamYard is per month to host more than 5 people on the rare occasions that it would potentially be useful. So, Ness, welcome. Good to see you. What'd you think of the debate? What are your thoughts?
First, to be honest, I also worked on something else at the same time, so I did not follow the debate very closely, but I still get the gist of it, especially the moment that you explained yourself about the 3 figures, and also the moment when Price got the answer wrong, or at least a part of the answer. He mistook the neutral for the deleterious.
Yeah.
That's one thing he did. So let's see here. And I also think it went better than I expected, because I was thinking it would probably devolve into a whole debate about what is the definition of information. Basically the same thing that happened with your conversation with Price, Dan. Like when you talked to him like a couple of years ago, you asked him what the definition of information was, and he just refused to answer it. He actually argued that he doesn't need to define information, but luckily that did not happen in this case, at the very least.
I think Paul did a good job here in that I tried to bait him into talking about information, because I thought I could pin him on it. And be like you can't actually tell me that this is not what GE would predict. And I think in his closing, he touched on it only for a moment, but it was in the closing. But I think the reason that this structure of the debate was much more civil, at least, like it didn't devolve, is because we don't actually have a lot of talking time. We don't have a lot of cross-exam time, right?
Right, so it's a little bit, yeah. Yeah,
so it's like very set blocks of speaking where we can try to respond to everything, but you can't like prod people very much in this way of the debate.
Yeah, I think you did an effective job of that in 2 ways there with the information thing. So one was when you showed the 2 distributions and had the arrow basically pointing from the random to the selected distribution, saying that's the information, that difference. That kind of like, Paul was not interested in disputing that characterization of information, which made it really easy for you to say this process builds up information. Yeah. And like that was it, because like Ness said, when I talked to him on this a few years ago, I said straight up, like, what is information? He's like, well, we can't define it. Okay. So I don't think he wanted to dispute your definition. But the other thing was a couple times you use the format to your advantage, basically taking the lack of a lot of direct interaction back and forth and using that as a positive by saying, here's a thing I've brought up multiple times that Paul has not even tried to address. And it's the whole point. If this is true, then that's the end, and he's not even mentioned this in any of his speaking times. And I think that was a useful tool or a useful approach to kind of get around the lack of direct interaction, which I think the format was cool. I think the format was good.
Yeah, I liked how fast it was. Like it felt over really quickly, actually. Like the formal part of it. So yeah, I think the format was really good.
So let me get to Andrew here. Andrew, it's been a while. How are you doing?
Ooh, I'm doing okay. Can you hear me? Is
Yeah,
my audio coming
you're
in?
great.
Hope I'm not robot.
Your thoughts?
Yeah. I agree with a lot of what Zach said earlier. My impression, just coming off of the debate as it just ended, was it felt almost like Paul expected Zach to defend the paper that you and Dr. Dan wrote, as if that was the only paper running these types of simulations, right. Which you pointed out, of course, Zach, and he didn't really touch on that, of course. And it was funny, people mentioning the chat is like, you should have defended the model more. Well, that wasn't exactly the topic of the debate, so I don't know.
It was, Paul never said, hey, do you want to have a debate over your paper? Right. He said, do you want to have a debate over the effects of mutations in evolution? And so to me, I'm like, okay, if we're going to do that, then what I want to do is I want to propose a model that actually makes predictions about the real world that includes only effectively neutral mutations and that makes very powerful and obvious and undeniable predictions that have like led to real world change. Sure, we could spend all day debating the specifics of a model, of a made up model in a paper that we were basically trying to mimic what Sanford did. But that to me doesn't actually resolve the problem. I want to see like biological data involved, and that requires talking about a specific model. Now, if he wanted to, maybe I should have foreseen that this is what he wanted to do. If he wanted to debate our paper, then I would have done a whole presentation on our paper, right? And that would have been a whole different kind of thing, but it was about mutational effects on evolution.
Yeah, you seem to misunderstand the point of your paper in that sense. The one other thing I did want to say was, besides the fact that you mentioned the infinitesimal model, and I do want to thank you for bringing that up because I was not previously aware that there was such a model accounting for all the mutations as effectively neutral, and yet so obviously they were still selectable in that sense, despite what genetic entropy says.
And the name of the model, the infinitesimal, literally comes from the fact that selection is infinitesimally small on each mutation. Right. That's where the name of it comes from. And it assumes that basically you have an infinite number of alleles, and if you have an infinite number of alleles, then selection is infinitely small, right? So that's why it's called the infinitesimal.
The one other point I wanted to say was I like how in a majority of the debate he was almost conflating, and I think you probably noticed this too, the genetic load paradox with Kondrashov with genetic entropy as if those are the same thing, which clearly you've talked about in your videos how they're not. So
yeah, so he seemed to actually say, that they were that genetic entropy is the Kondrashovian paradox. Like that's what he seemed to be suggesting here, which is not what Sanford said. Like that's Sanford's model is his own thing, but he seems to, like Paul seemed to take the side that no, Kondrashov's model is what this is all about. And if I had known that, I would have done a whole thing about Kondrashov's model, and I would have talked about the problems of Kondrashov's model in a lot more detail. I tried to do it a little bit.
The goalpost has moved again.
But can we just appreciate that the problem there is that the creationists having these conversations don't understand the underlying population genetics to the extent like that Zach does. Like there's a whole like history here, and there's very subtle differences between these various models. And if you're not immersed in it, like for your job, then you're not gonna understand it. And Sanford does this in his book, where he's talking about genetic entropy and mutation accumulation and whatever. And then there's literally a one paragraph thing where he switches gears and he starts talking about an extinction vortex in a population, which is where you have a population that is below the MVP, the minimum viable population, and you have lots of genetic drift and inbreeding, and you have a sharp increase in homozygosity, which is the exact opposite of genetic entropy, which is lots of mutation accumulation which necessitates heterozygosity. Yeah. And it's literally, there's one paragraph in Sanford's book where he just like flips what he's talking about, And he doesn't seem to realize that he has just reversed the polarity of like what is happening in the theoretical population he's describing. Yeah. And I think that is a common problem here, where the creationists having this conversation don't understand the sometimes subtle differences in the different kind of models and problems that they're talking about.
I think Paul actually did bring that up at the inbreeding and conflating the two as well.
Yeah.
Also, do we maybe a good idea to bring up Kimura's paper and show the exact line where Kimura says, I exclude beneficial mutations for the purposes of modeling neutral evolution?
I'm going to pull that up while we're chatting so I can show it on screen at some point. Thank you for reminding me. While I'm doing that, is it Eloy? How should I say that?
Hey guys, my name is Eloy.
Welcome. I don't know you, but welcome. Did you watch the debate? What did you think? Give us your thoughts.
Well, first of all, thank you guys for allowing me to participate here, and allowing me the opportunity to share my thoughts. I have 2 points to make, 2 points among so many, but I'll narrow it to 2. But I will say that I was in the audience in the debate, and I was the person, if anybody saw it, where I mentioned, if anybody saw it, that the framing of mutations. Do you know who I am then?
I remember exactly who you are in the yes. Yep.
Okay, so I explained that the framing of mutations in their model, or at least the assumption, they didn't say it outright, is the equivalent of saying, like, from my position, Marvel Comics, the Swamp Thing, a mutation is always a negative, that just a grotesquely something that comes out of the swamp. And this is a sort of like definitional assumption leap into an area of pop culture, as opposed to like just data, and the definitions used by scientists in their respective domains. So the 2 distinctions that I wanted to offer and see what you guys think, which I assume is fairly tame, is that one, there's this idea of domains, and then there's this idea of models that I'd like to distinguish between. Domains, for instance, under the umbrella of evolution, or better said, science, the practice of, and then the specific disciplines under that umbrella down, and people working in their respective labs and studying whether it's population genetics or plants or whatever the case might be, botany, etc. All these genetics in specific, all these are sort of like branches that people are involved in across the globe, and these are the domain. Well, that type of domain has constraints, rule sets in which people perform their activities within. Okay, so now the other thing is, there's domains that are outside of this science practice, where you have philosophers. There's crossing of little ideas and concepts, because what science does is that they take language and they use language, which is really a secondary subcategory. You have data, the drawing of data, which people perform, and then you have the explanation of the data, which people then interpret using the data in the language toolbox, which is different in a very unique way. So this language, then you take something like mutation, and you'll all of a sudden have a situation where, well, wait a second, I remember when I was growing up back in the 80s, I used to go to the comic shop around the corner, and I saw Swamp Thing in the comic book. And so to me, the definition of mutation outside of my study, because I'm not a scientist, let's say, it would be Swamp Thing, the Marvel Comics special issue number 53, this, that. And so now the domain of the creationists um, is seeing an issue with what Zach, the doctor, is is explaining, and then these words come up on their screen, and then they try to work out a plan, a pathway, in order to topple the science. And finally, I'll just say this, and I'll see what you say. I believe, with all that that I've just said, that there's absolutely no contradiction, and even why bother in terms of science and faith, because the data is always going to be the data. You cannot, I mean, you can interpret the data differently, but the data is always, if you see genes ordered after recombination, and this patterns back to a little group somewhere in, I don't know, Central Europe, and then it goes back further out towards Ukraine, and then further back down into Asia, and then down into the Middle East, and then you see the tree of humanity, as we see in popular, if you see that, the data is the data. We're attaching coordinates, definitions, so we can actually refer to it again in the past, in the next time around, so we can share information. Well, my point is this, that we have two different domains occurring, two different models. One wants to land with faith and no, evolution is bunk. But the problem is that evolution is this huge domain with subdomains in it. They compress it into this one thing and then try to negate it, and it's never going to work, because a person like the doctor is going to say, well, look, the information, you can switch out the simulations, the models, the papers that offer one thing or the other, but they're using the same basic tool set to produce the data. So you can have an argument over, oh, well, they made a mistake here or there, but the information is still the data. So my whole point is that we have data, and then on the other hand, we have interpretation. Now, finally, interpretation is where the creationists, if used properly, can easily wiggle out of the whole entire issue by just simply granting evolution in their particular domains what the data says. It does not bypass the concept of immaterial, immaterial faith or any of that. You can argue that or against it, but none of it is. It's just different models applying the different criteria.
If I can jump in to say something here, I think that the big problem, right, is that data exists in the world. Data is just facts, right? There's lots of facts in the universe. But science is not just the task of gathering facts, right? Science is about interpreting facts and understanding facts and explaining those facts. And to do that, we use theory. And theory is only as good as the predictions it can make about the facts that we're going to observe and that we haven't observed yet, that we're going to observe in the future, and things like retrodictions that we can use to help explain the past, right? So a model is only as good as it can predict the data at hand, right?
As long as we do not insert leaps into that interpretation using the data as a crowbar. This is the key distinction, because we do see people make predictions, right? And that's fine, because you're using the same tool set. If you use the tool set of genetics, you're always going to arrive at genetics, and this is kind of what you're suggesting. It's always you're in a closed rule set where genes are dictating, hey, this is where they appear in combination for this specific, I don't know, sample, ancient sample, let's say, if it's ancient populations or whatnot, and you're going to see the order of the genetics. That's fine. That's not what I'm saying. What I'm saying is leaping from one thing to the other, creating ontologies of who knows what, which is just narrative stories. So what I'm suggesting is that if one creates a theory and the story is fantastical, which is not what I'm saying in this case. I left a record on that debate showing that that's not the case. But what I'm saying is that we can also not elevate the narratives above the data. There's a leap in between those two. This is true not only for, it's true for everything. You have data, and then you have the interpretation, the explanation. It doesn't suggest, I'm not suggesting that explanation is.
I've got to be honest with you. I'm completely lost. I'm not sure what we're talking about anymore, or the direction in which we're going. I am in a swamp, in a haze, and I'm wandering like this, and I don't know where I'm going.
So if I can try to add something, so my thought hearing all of this, Eloy, which I appreciate you joining in your contribution, is you very frequently hear creationists will talk about how it's not, we're operating from the same data, it's different interpretations. And then if you get, Nathaniel Jeanson, for example, he did something a while back that I reviewed, and I forget if it was with Zach or somebody else, but at one point he was like, and you have to look at these data and you put your Bible glasses on. And it's like, well, the data exists independent of the Bible glasses, sir. And I think during the debate, if I recall correctly, it was you in the chat, Eloy, who said something about mutations and how creationists take this idea of mutations as like this very binary thing of either it's good or it's bad. And that is a false dichotomy. But they have it as mutations are good or bad, because in their kind of way of interpreting how genomes work or whatever, by imposing this good or bad dichotomy on mutations, that gets them to the conclusion of their model, right? Something to that effect. I'm probably butchering because it was, a rapidly moving side chat.
No, that's exactly what I was saying.
There you go. Cool. I'm glad I caught that. And that was, I think, a really important contribution to that, the various threads of conversation going on in the side chat, because I think there were a few times during the debate where Paul kind of reverted, if I can say it, to his Bible glasses approach to this issue and kind of got away from the more empirical view that like the debate was kind of structured around. And am I interpreting what you're saying? Am I getting the gist of what you're saying?
You're spot on.
Cool. There we go.
Spot on.
And I want to summarize this with just what the comment I pulled up a little while ago from Petit Flower. If your model conflicts with reality, your model is wrong. And the data are what they are, right? You make your observations. They are what they are. Correct. If your model says something else should happen, the problem is not with our observations. The problem is with your model.
Can I give one of the best quotes of all time by J.B.S. Haldane? So Haldane is the father of the genetic load. He derived it in 1937. And in that same year, he wrote in a book called Adventures of a Biologist, he wrote, "No scientific theory is worth anything unless it enables us to predict something which is actually going on. Until that is done, theories are a mere game of words, and not such a good game as poetry."
Let me add some points. I agree with that 100%. But I'm not arguing against that. Just to make it clear, the reason why there's a flurry that you suggested, the potential reason you're saying this is because I'm actually bringing up something that's a structural situation. I started by saying that there's this issue about domains and models. This is not necessarily, the point is this: we're right now not in any sense right now, you everyone on the panel, myself, are not performing science, period. This is not what's happening. What's happening, if you clear the decks and look just at what we're doing, we are communicating using the English language, which is a communication tool which has words, and those words have definitions. What I was trying to say here, and what I was suggesting over there with the Swamp Thing bit and this and that, although not typically inside the argument between two people in a debate. It's what's happening if you stand over and look at the debate from afar, which is not necessarily a common practice, but whatever. Um, is that in his model, the other gentleman with the lab coat and whatnot, the creationist, what happens is that from their model, they're taking a slice of evolution or genetics in order to constrain into their argument. Their model is that. Your model is you're pulling from the data and you're pulling from all the data. You don't care, generally speaking. I'm being a little bit loosey goosey here, but like you in that debate pulled from different papers, and you said at one point you said, look, you can pull from here and there. It's not the specifics within the thing. We're using this rule set and these results. Now, here's the thing. You and the gentleman over there are both interacting, communicating, arguing, debating through language. This is the only way you can transmit, and this is what I'm saying. You're trying to convince him to whatever degree, and him to you, or to show the audience arguments, and people are set in their ways from their models back home, sitting in their chairs. I'm watching this and I'm thinking to myself, I will grant Zach, Dr. Hancock, everything he's just said, because he's pulling from the data, and his words, if they contradict the data, those
Keep at it. I need another beer.
those things are a problem.
I feel you, Zach.
And then the other gentleman, and just to wrap up, then the other gentleman, I can see what's happening, that they're trying to massage what genetics says. We all know that mutations are something constant. Recombination is every time a person is born, they're mixing. It is a constant. There's no need to say binary, good, bad, or indifferent.
I just want you to know, Eloy, I am not laughing at you. I am following the side chat, and they are having the greatest time right now. I see exactly kind of where you're going with this, and I follow. Yes, I generally agree with what you're saying in terms of this kind of interpretation of objectiveness. Yeah, and
you yourself are hosting this on your channel. You've brought me in. There is nothing for you to grab on to in terms of communication other than the language and maybe the visuals, your sensory, my sensory, and this and that. What I'm getting at is this: apart from the whole genetic argument back and forth, whether religion, faith, genetics, this and that, these are all models, and people are. And I'm not minimizing the genetics. I'm not trying to do that by any. I believe in the genetics. There's no way around it. What I'm saying is that in a debate, if you bring a model that's missing context and you're leaning on your belief system and not taking the context for the data that it represents, then you're never going to come to an agreement. In other words, both of you are in a loop in that context of that argument. You're in a cyclical short circuit loop. Because
we are in a loop. We are in a
All right, Eloy, I appreciate it. I got other people I want to go to. I first of all, chat, you're killing me over here, and my face has no indoor voice. So, and I did not make that up. I stole that from somebody. I forget who. But my face has no indoor voice. And reading the chat, that was apparent. Chat, you were being very funny. I want to go to Fergan. Fergan, I also do not know you, but I appreciate you being here, and I would love to hear your thoughts on the debate.
So this specific debate, I unfortunately did not watch, but I'm generally aware of Paul Price's work. I'm generally aware of genetic entropy, and I'm aware of you and Mr. Zach Hancock's work on. I believe you released a paper about basically debunking genetic entropy. I believe, Dr. Dan, your PhD was on the actual existing version of genetic entropy being not correct because it's just a silly idea.
So not specifically, and I think when I was in grad school, I didn't even know the term genetic entropy yet. But chapter 4 of my dissertation, for anyone who wants to look it up, is on my attempts to drive viral populations to extinction via lethal mutagenesis using a cytosine-specific mutagen. And let me tell you, it is an absolute banger of a chapter. And
future reading Dan's dissertation stream when?
yeah, it will make more sense than the various streams that have gone on of people reading Mr. Kent Hovind's dissertation. Let's it'll make more sense than that. But I will tell you, I will say, so my work, once I learned about genetic entropy, I immediately went, nah, that's all BS, because I tried and I couldn't show that that's what was happening, because I did drive the phages to extinction. But what I couldn't do is show that they went extinct due to mutation accumulation over generations that could not be selected out, right? So I couldn't demonstrate the error catastrophe, even though I did demonstrate extinction. And I think that is relevant to the conversation, which is cool.
Yeah, because I mean, if genetic entropy was a thing, all they would have need to done is basically prove it, like draw some bacteria generation into extinction. Here you go.
Show that it happens.
Yeah,
right.
I gave like a series of failed predictions of genetic entropy, and I should have gone back and emphasized those more, because one of them is that if a population has large amounts of genetic diversity, then they should have proportionally much lower fitness and much greater probability of extinction than one with much less genetic diversity. And of course, this is the exact opposite of what we see in nature. The lower the genetic diversity, the more likely you are to go extinct. And this, to me, is a fundamental failure of the idea of genetic entropy, that if mutations are overwhelmingly deleterious, then high genetic diversity population should be on the brink of extinction, and yet they are not, right?
And you can go even further than that and say, if you have a mutation-saturated population where every possible point mutation is present in that mutation at any given time, then that population, according to genetic entropy, must inevitably go extinct, because everybody is now on that terminal slippery slope.
Yeah,
and you can make those populations in lab, and it doesn't happen.
Oh yeah, I mean, I think Lenski's experiment is still going on, right? And
oh yeah,
I mean, those bacteria looks perfectly fine to me.
Yeah, they're not going extinct.
Yeah, I mean, in general, I think it's just like funny that when did Sanford, I think it was Sanford who came with this idea, right? The whole genetic entropy stuff.
Sanford, 2005, yep.
2005. So it's been nearly 21 years, which is, for reference, I'm 24. So it's basically as old as me. And even though it's like, I mean, my biology experience is basically like AP Bio 1 that I took in high school. So like I have a very surface level of understanding of biology. I mean, I'm a computer scientist, which, you know, the fakest of sciences. And like,
the fakest of sciences is evolutionary psychology.
Yeah,
I quote you a lot on when evo-psych stuff comes up, because it's
So to be fair, computer science is becoming a particularly important component of evolutionary biology. Like most of my research is actually sitting at a computer and coding software programs. So I think that I don't want to diminish the importance of computer science. It plays a very large role in theoretical evolution.
Oh yeah, absolutely. Like, I mean, in the sense that, especially on undergraduate level, it's definitely like way less intense compared to like other quote unquote hard sciences. Like, I feel like it becomes more scientific when you do actually like do your master's / PhD and kind of get into academia.
Sure.
It's more for like a profession thing, but sure. Yeah.
So I wanna just highlight this question from Petit Flower. How many generations of E. coli have we observed? So specifically in the Lenski experiment, I believe, and I'm looking it up right now, I believe at this point it's over, I want to say it's over 100,000, because I remember as of a few years ago it was over 80,000, but I forget when that was. But at the very least, I know for sure it's in the 80,000. And it may be more than that. I don't know if it hit 90 or 100.
It's at this point it's gone beyond Lenski's career.
I know, because it's down at UT Austin
passed
now.
it on to the next people. Like he is retired now.
Right,
wow.
it's down at UT Austin, and it's just continuing. So it's right. At last I checked, it was 80-ish thousand, but that was a few years ago. I remember updating my course material for that, so it's more than that now. But those bacteria are still chugging along. Yeah. So let's see, couple things here. Couple chats I want to highlight, and let's see. So we have. So this was pretty good, Zach. I thought you would appreciate this. It was pretty funny to hear him mention Lynch. Like Dr. Zach doesn't frequently reference them in his video.
Yeah, it's like Lynch was one of the most important population geneticists when I was in graduate school. I was actually required to read his book, The Origins of Genome Architecture, for my prelims. I've literally fought my prelim advisors on Lynch, so I'm very familiar with Lynch's work.
Yeah, that kind of reminded me of the moment. It wasn't as bad, but it was along the lines of, there was a conversation that our friends Dapper Dinosaur and Jackson Wheat had with some rando that Jackson found on like Twitter or something. And they were going back and forth about something, and junk DNA came up, and Dapper and Jackson were explaining like the evidence for the existence of junk DNA. And this guy, who apparently had no idea that anybody he might encounter reads things, says, "But have you heard about ENCODE?"
Yeah, I remember this.
As though people choosing to have a conversation about junk DNA would not have heard about ENCODE.
It was even worse than that, because when they were explaining the evidence of junk DNA, they mentioned ENCODE before he mentioned ENCODE.
A question about ENCODE, by the way.
Yeah,
because
go for
I keep hearing about it a lot. Like I in general, like I use. Well, most of the time I listen like to quote unquote science friends videos in the background while I'm doing something. So it's all kind of filtered to whatever I'm doing at the moment. But with ENCODE, was it a creationist project originally?
No,
it wasn't.
No.
My bad.
No, it was a multi-billion-dollar international project, mostly funded by the National Institutes of Health, but also various other agencies, including some private agencies. But it was seen as a continuation of the Human Genome Project. And what they wanted to basically do was see what all the stuff in the genome does. Like that was their sort of goal. And they had some pretty broad categories that ended up being the problem, right? So basically, they applied functions to biochemical activity. Anything that your genome does was given a function. So let's say it binds a transcription factor. That's its function. It happens to bind a histone. That's its function. So like basically anything that does any kind of biochemical activity or is transcribed, that's its function, right? And so the critique here is that, well, junk DNA never says that the DNA doesn't do anything. Right. And in fact, what you expect in a, biomolecule in an aqueous solution is going to do lots of stuff. It just turns out that those things are not actually necessary for you to survive and reproduce. And that's what we mean by function in biology. So they used an extremely loose definition of function that basically counted anything that happens in the cell is a function. Right. And that was the
people who were leading ENCODE were like primarily biochemists, and not
they were biochemists.
They looked at any biochemical activity that they can talk about, basically.
And this is a good point, because that's how molecular biologists think about function, to be clear. Molecular biologists are like, go in and say, okay, this binds to this, binds to this, binds to this, that's everything's function. But from an evolutionary biologist perspective, and to be clear, we coined junk DNA, so we defined what it is. It's our thing. And so if we say, well, those things might happen, but they don't impact the survival and reproduction of the organism, then they don't have a function and are junk. Right. But a molecular biologist is looking to see, what does the chemical interaction do? And they might do things. And sure, go learn what that is. That's important. But don't tell us that you've overturned junk DNA when you've completely redefined what junk DNA is.
Can I chip in if I could be so bold? You've mentioned definitions various times, and in fact, the conversation is just as I explained earlier. Although it probably was slightly uncomfortable, shocking. I read some of the comments, personal as opposed to talking about the actual issues. It's incredible, but this is normal. This is human beings interacting. Definitions is the issue, and models are the issue, dependent on one's perspective. The debate showed exactly the circuit again and again, where you have somebody with their definitions imposing definitions on another domain, and vice versa. Not throwing blame around, but you have different models that simply are interacting using language, and they're never gonna, like, for instance, how many creationists exist around the world? What's the point of having is it education to educate people? Well, what happens when they don't want to meet the rest of the data? What happens when they say, no, we don't want that part?
Oh, Dan, you muted.
Well, before we get to
I'm muted now. So I have an answer for that.
Okay.
So there's two things. One is that there are like real definitions for things, and then there's made up definitions for things. And creationists love to make up fake definitions for things, and it's very frustrating. And
Can I
they
push back on that?
Well, let me get to the second thing though.
Okay.
And then the other thing is the why. And Zach, I won't speak for you, but I'll speak for me. It's like why I do this is because in the United States, creationism is not actually about science. The science doesn't matter. It's not a scientific project. They don't care. They're LARPing science. If they cared about the science, they would participate in the scientific community, in the scientific process. And they don't do that because they don't care about the science. In the United States, creationism is a subset, a component of white Christian nationalism. It's a political project, not a scientific project. And that's so they can do all their stuff, but it's in this ecosystem that is not designed to engage with the rest of the scientific community because they are not participating by choice in science. And they love to play the victim card of, oh, we can't, whatever. No. You come to the conferences, submit your papers, do whatever.
Okay, I number one, I agree with your second part about the whole Christian Christian national part, and also with the using that that concept of creationism to impose or to limit evolution. I agree with that. I see that as well. I don't think that there's but I would not what do you call it, broad stroke that. There's variations within that too, that they don't go to that extreme in terms of people. That you can have a person that believes, oh, I don't know. You can be a person that's very much invested in oh, I don't know, let's say philosophy and science in terms of evolution, and you can be within those domains or a third domain and so on. But then you have this closing off effect to impose your vision counter to what the data shows. I agree with that. But to go to the definition part that I said I wanted,
All right, and then we're going to move to the next thing. Go ahead.
Yeah, the definition part. I agree that there's agreed upon definitions, but these are consensus established long ago or recently. Definitions are all, words and language are always consensus based. Like the doctor said, we own this definition because we inserted that definition according to our domains, et cetera, et cetera. So he's basically explaining that very thing. People impose definitions, and then consensus hovers around it, and you anchor definitions. But definitions are malleable. I'm not saying the data is malleable. I'm saying language is malleable.
Okay.
Malleable.
I got you. I hear you.
By the way, I got
we're drifting a bit afield, so I want to go to now genetic philanthropy, and then and then Nestling, I want to pull up the paper that you have pulled up, and I see in the preview you have highlighted the exact same paragraph that I've highlighted on my screen that I was going to pull up, but I'll let you do it. So, what were you going to say?
Oh, me?
Yes.
I was just going to say that in the meantime, I pulled up Kimura.
Let's do it. So, little
Yes.
preview here for folks. There was a spot in the debate where, so there were actually a couple times where Paul was kind of getting into the head of various authors, Sanford and Kimura, and kind of reinterpreting their words to say things that they didn't necessarily say or change the meanings a bit, and like away from the plain words that were written on the page. And my favorite example of this was in the famous Kimura 1979 paper, which, Nestle, you want to just like zoom in on that a little bit so we can read the text? You want to just blow that up a little bit for us? There you go. Hit that plus. Yeah. Make sure we could read that paragraph down there that you had highlighted. Because
I lost the highlight.
in Zach, do you want to take a minute to talk about this paper? Because I know this is like your thing, but I'm also happy to, because it's also my thing. I love a good Kimura paper, but go for it.
Yeah, I mean, I can put it in the context. So this paper, to give the historical context, this happens in the 1970s. In 1972 or 73, Tomoka Oda proposes the nearly neutral theory of molecular evolution, because all we have at that time is basically protein data. And the protein data seems to suggest that selection is acting. Right. And Kimura's like, oh, crap, my theory is based on strict neutrality. And yet it seems like selection is actually behaving. It's actually acting. And so he co-authors a paper with Tomoka Oda. But then throughout the 70s, he basically works on nearly neutral theory alongside of her. And so this paper is a theoretical investigation of what happens if you consider a distribution of fitness effects such that they are approaching neutrality and less. So he calls it selective constraint or effective neutrality, right? And that's basically what he's doing, is he's interested in how much heterozygosity should there exist in a population, and what's the rate of molecular evolution given that distribution, right? So that's what he's investigating. And the reason that he does it in the way that he does is Tomoka Oda's original theory was called the slightly deleterious model. It wasn't called the nearly neutral. At the time, it was called slightly deleterious. And so he models purely slightly deleterious alleles in this model to try to investigate those things under that context. So that's the sort of historical framing of what he's doing in this paper.
And that gets us to this quotation, which... Nestle, I'll let you read it since you pulled it up if you want. But this is just so perfect.
You can read it because my accent is not very good.
I got you. So I will say, perfectly understandable. Like everybody, I don't think anyone has any trouble understanding you, to be clear. So in this debate, I commented in the side chat at one point because Paul was talking about the distribution of fitness effects in this paper, because it's the theoretical, I'll say, distribution that Kimura used that then Sanford used as he modified it for the distribution that he put in his 2005 book, Genetic Entropy and the Mystery of the Genome. And as I and Zach and many other people have pointed out, that distribution was not empirically determined. That was a theoretical distribution that purposefully excluded certain mutations, and Kimura explained in the paper why. So you've got John Sanford, and then everyone citing John Sanford, including Paul, saying like, well, look, Kimura, he had no beneficial mutations. And then Kimura, in the paper, explained his distribution thusly. He said, note that in this formulation, we disregard beneficial mutants and restrict our consideration only to deleterious and neutral mutations. Admittedly, this is an oversimplification, but as I shall show later, a model assuming that beneficial mutations also arise at a constant rate, independent of environmental changes, leads to unrealistic results. And this actually came up directly during the debate when Paul showed that exponential graph above the carrying capacity. He was recapitulating a problem that Kimura himself identified in 1979.
Yeah, that's why we call it in the paper.
Just a little bit behind the curve.
Like, just a few decades, right? Go ahead, Zach.
This is why we called it a Darwinian demon, is because, in effect, and Darwinian demon is a term applied to any model that includes beneficial mutations independent of environmental context. So that is to say, there's no fitness landscape, right? You could just increase fitness forever. And if that's the way you model it, then what you find in models is they explode, right? They just blow up because beneficial mutations fix with much higher probability than deleterious ones.
Right.
And so they overwhelm the population. And that's what his model shows. That's also what we mentioned in our paper. Paul presented it like we were trying to hide it, but I literally wrote in the paper that I'm pretty sure this model will lead to a Darwinian demon. So like I mentioned it, I gave the term in the paper. So I mean, and in fact, Kimura shows the math later on. At the very end, he includes a distribution of slightly advantageous mutations, and he shows that ultimately the rate of molecular evolution ends up being proportional to the effective population size, which is enormous, right? Which would lead to way, way faster evolution than ever observed. And that's because beneficial mutations are completely environmentally contextually dependent, right? Like it's where are you in relation to the adaptive landscape? If you're on a peak, there are no beneficial mutations. If you're far from the peak, there's a lot of beneficial mutations, but you exhaust them as you approach it, right? And without that modeling context, then the models don't make any sense, right? They break down when you include that beneficial distribution. So he avoids that problem by not including them here. I hope I've cleared that.
Can I ask a question about beneficial mutations?
Yeah.
So, when I was watching the debate, another thing, and I couldn't express it. I mean, I expressed it with basic but if someone has to say, we observe this benefit, but the way I understand the genes interacting, it's not just the location and the benefit that you're observing. It's in combination with all the genes working together. It's a landscape of, this is my terminology, of interacting genetics that produce variations that we don't necessarily, I don't know that, have we mapped it all? I don't think so. So there's negatives and positives. So my question is, this idea of landing on this is beneficial isn't just beneficial. There's other things attached to it.
Of course. Yeah. So whenever we talk about beneficial and deleterious mutations, especially in the context of lab experiments, to be clear, all of DFEs are derived almost entirely by lab experiments, mutation accumulation experiments, or they're derived statistically in nature, which is our attempt to do it in humans. But these two things are very, very hard to pin down. But a very important assumption underlying that is that you can have just a beneficial mutation, like you can apply a selective effect on one individual mutation. But you're hitting on something really important, and that is that genes are not independent of each other. There's what we call epistasis. So genes are constantly interacting, and their fitness effects are actually dependent upon the phenotype that they produce. So a beneficial mutation in one context is deleterious in another context, and vice versa. Right? Because these things are not independent of each other. And I tried to talk about that in the debate by I gave the example of the fitness distribution with all the different haplotypes. Some mutations increase or decrease the trait, and it actually depends on the arrangement of those mutations, not the number of mutations you have. And so alleles don't actually have fitness effects, is what I'm trying to get at.
I saw that.
Phenotypes that have fitness effects.
I saw that in the debate. My question. I saw that in debate at various points. I didn't know how to lay it out in a little comment bit, but I saw the gap that was occurring. And again, it was this rigid binary view of genetics that creates this contradiction.
Yeah.
That's all I wanted to say. Thank you.
What I also want to add to this is also it's also related to the term fitness, and it's unfortunately that fitness is often very misunderstood. Like when most people hear fitness, they think it a little bit in terms of like, oh, you went to the gym, you are really strong, or you went to school and you're really smart, you're the best of the best of the best. But in evolutionary biology, fitness is more like to fit in, like a square object fitting into a square hole. How well it fits into a particular environment. That is how fitness is used in evolutionary biology. So it's really context dependent and not in an abstract, absolute sense.
Yeah, there's an interesting Yeah, there's an interesting thing that emerges from this. If you are familiar with Sal Cordova, then you know that he loves to cite.
I wanted to bring him up. Sorry, Zach, for cutting you. I was waiting to bring him up.
Fergan, we'll get you next.
So Sal Cordova loves to cite the Confusions of Fitness paper by Lewinton and RU. And what's really important about that paper is they draw this distinction that Neslick just made, in that Darwin thought about fitness as fit to the environment. That's how Darwin defined fitness. In population genetics, we often define fitness actually by the number of offspring or the probability of the number of offspring that you have. And you can relative to other individuals, or it can be absolute, in which case it's
Can I just jump in and say the way I like to describe it in my 200 level intro evolution class that I will be starting in a couple of weeks. I'm very excited for. I do my giant class and then I do my teeny little summer class. It's an individual's contribution to the gene pool of the next generation relative to the other individuals in the population. Like, what is your relative contribution is how I conceptualize fitness at kind of that level.
Yeah, I think that's a good way to think about it. Often people want to connect it to ecology, like we're interested in population dynamics. And so to do that, you basically have to unrelativize it, and you sort of devise it as how many offspring do you have? Because then it's connected to population growth rates. Yeah. But the key distinction here, Nestle, that I was trying to make is that sometimes those two things, those definitions actually equal each other, right? In the Darwinian case, those definitions equal each other. But as soon as you include drift, those definitions become fuzzier. And that's what the Confusions of Fitness paper is really all about, is what does fitness mean when you're including chance reproduction, right? Because then that can lead to individuals having more offspring solely by chance, not because they necessarily fit the environment better.
That's a good point.
Do you see what I'm saying? And so that's really what the Confusions of Fitness paper is about. And I tried to explain that to Sal Cordova. And his response was basically like, you're just dodging. It's like, no, I'm explaining to you the paper. You just don't understand what their point is.
There are so many situations, and that's a really good example of it, of the phrase, and I hate to use the phrase because it's so good, but it was invented by a Republican, which makes me angry, but it's really good. But I can explain it to you, but I can't understand it for you.
Oh my God, that is a good one, yeah.
And there's so much of that goes on in this conversation of, look, you're asking a question about this very specific thing in evolution and population genetics and whatever, and I can sit down and take 45 minutes and explain it to you, but I can't make you accept that my answer is an answer to the question that you are raising, right? I can't do that.
People don't have independent of, so when you explain something, you know.
Hey Eli, hang on 1 second, because I want to get Fergan in, because he had mentioned wanted to bring up Sal Cordova, and there was something in the debate, Zach, that I wanted to kind of use as a segue to that, Fergan. So just give me a second, and then we'll throw to you, because I was optimistic, let's say, going into this, Paul talking about his months of preparation for this debate, that it wasn't just going to be a Sal Cordova-esque, like, here's what this smart guy said, and here's what this smart guy said. And then in the chat, and I have somebody, I have it starred that I want to pull up. Somebody clocked here. I gotta find, here we go. It was Johnny Atheist said it was great to basically see the fact check from Dr. Dan and Andrew Cummings as Paul was speaking, then Dr. Zach basically saying the same thing. And a lot of that was Andrew and I just laughing about, like, there's Kondrashov, there's Lynch, there, like, we knew beat for beat.
Bingo cards.
Right. We were doing the bingo cards, and that's a hallmark of what Sal does. If you're familiar with Sal, you know he has, like, his list of quotes that he goes to, right? And so I was optimistic that wasn't going to happen. And then that's exactly what happened.
Oh, damn. You got your hopes up.
I know. See, Andrew, just never get your hopes up. So I want to go to Fergan. Fergan, I want to use that to jump to you. And then, Andrew, we can go to you next if you want.
Sure.
Oh, yeah. I mean, with Sal, I was also just going to bring up the fact that I don't fully remember what his definition of fitness was, but I might remember he had I think his definition was close to, like, things getting better in some very vague, like, Ubermensch sense, let's say, which doesn't mean anything because it's all context dependent. And then you explain it to him, and then he just goes, it's a horrible definition. And it's like, yeah, if you redefine words then I guess the arguments get wrong.
I've had multiple like hours long conversations with Sal about what fitness is, and
I
at
listen
least
most of them.
and at least 2 of them are on YouTube. And so you could probably watch 5 hours of me talking to Sal about what fitness is if you really wanted to.
I mean, at the end, it's just I don't like this definition because it doesn't
That's
fit
exactly
my...
what it is.
Exactly.
Yeah, and that's their whole that actually it plays into the kind of the backstory of the paper from Zach and I from a couple of years ago, because it was about the fitness maximalization stuff, and Sal was a contributor on the book chapter on that. And I spent freaking hours trying to explain to him that, like, you guys, here's the bait and switch you're doing with the definitions of fitness. That's not what fitness means. You can't do that. And they're just like, nah, I don't care. You just do it.
Yeah.
It's like, okay, if you want to like base your attempt to overturn evolutionary theory on fitness doesn't mean what everyone says it means, then fine. But literally nobody is going to take you seriously.
Yeah, one of my favorite illustrations to explain how fitness in evolutionary biology is very different from what most people would think of fitness is the mola.
That's there you go.
Ooh, nice.
Fitness is more interesting. I mean, obviously, there you go.
Right. Oh, that's also a good illustration. But
it's all about the information economy.
Yeah. Are you familiar with the ocean sunfish, Dan?
Which fish?
The
ocean sunfish, the mola. Yeah.
I feel like I've heard this one before.
Yeah, they have like
like
billions of eggs.
Really big fish.
Well, that's
Yeah. So it is a really successful fish. They are found in every ocean. They are like huge numbers of them, but they are by all accounts of any human aesthetic preferences, is the stupidest things ever. They are very slow. They get parasitized constantly, and they like seals. Just eat chunks out of them, and the fish can do nothing about it. Yet they are so successful because they fit really well in their particular niche that nothing else can outcompete them. They eat jellyfish, and nothing else eats jellyfish.
I think that's pretty cool.
Why they are so successful.
That's gross.
I don't know. I think that's a pretty noteworthy trait.
Yeah. Andrew, go ahead. What were you going to say?
Oh, kind of just bringing it back to the Kimura paper. I actually had a question for Zach, because it seemed like in the debate Paul was kind of making a hissy fit of the distribution of fitness effects that you were using in your paper versus what Kimura was, what he thought Kimura was using, which again, as you point out, wasn't an actual empirically derived distribution. Like, do you have any like thoughts or what he was trying to convey there? Because I couldn't really understand the point he was trying to make.
Yeah, so the point that he was trying to make is that the distribution that we used to him included fewer effectively neutral mutations than what should have been included. That was sort of the argument that he was trying to make.
Okay.
And the difficulty here is that we weren't trying to model Kimura 1979.
Right.
We were trying to model an empirical distribution, which has lots of lethal mutations. When you look at a lot of empirical distribution, they actually are U-shaped like this, because a large number of mutations are highly lethal and basically kill you in utero, right?
They just break something that you critically need.
Yeah. And so because of that, we had to make a modeling decision because I wanted to try to include both those highly lethal ones and the effectively neutral ones. And so if you do a selective effect of like -0.5, that on a gamma distribution, that leads to a distribution that looks like this, but it has a long tail, right? So you do get a lot of deleterious, but most of them pile up around 0. And so basically his argument was that we didn't have a broad enough effectively neutral distribution relative to what he thought it should have been. He cited Schreiber, which is a paper that I actually know who Schreiber is. I know him personally, but I wasn't actually familiar with the paper specifically, so I don't know their distributions. I'm pretty sure their distributions are based on statistical inferences, but I don't know it. So I couldn't really respond to what that distribution was, but that's what he thought we basically should have been doing.
Would the distribution have also depended on the effective population size? Because I'm sure that would.
Yeah, the distribution.
The one you used different from the one that he was thinking about.
It was. He was using he was trying to model a human, right? Like humans specifically. We were trying to model something closer to what Sanford did, which Sanford didn't actually model humans. We used basically a chromosome, whereas Paul was trying to do a whole. I bet it took him so long to run that simulation too. I was like when he was talking about this, I was like, "Oh, dude, no, you didn't." I was man, I almost wish he would have emailed me. I could have helped him. It would have
gone a lot faster. I'm sure.
So much of his RAM running that, that was crazy. But anyway, so the distribution that he was using, he was trying, I assume, to match the Schreiber paper, but I don't know the Schreiber paper, and I would have to look at his GitHub code, which I'm glad that he posted, so we can actually see. Because he said that the way he modeled selection was under a Wright-Fisher model that he tweaked to become effectively Wright-Fisher, which is possible, but that means that you had to do something funky with selection, and I don't know what it was. Right. So because I haven't seen the model ahead of time, so I would kind of have to see it to know the details of it. Right.
Would it be mean to kind of say I'm kind of skeptical of his results until someone's looked at the input parameters?
Well, I think that the important thing is that these, even our model was not meant to be a real prediction about
realistic.
nature.
Yeah.
But let's be really clear. We were not saying this is how nature will work. We're saying the way Sanford modeled it will not lead to decay. Right, that's not actually what is going to happen in natural populations. What you should be doing if you want to know what's happening in natural populations is go look in natural populations, right? And what you end up finding,
what an idea,
is that despite however you decide to measure the genetic load, whether it's the stochastic load or the mutation load, you find lots of load all across natural populations and no evidence that they are uniformly declining. And not even any evidence they are declining based on their load percentage. This is a huge problem in the genetic load literature, is that the predictions don't actually match population persistence.
Yeah.
Right. So that's a long-winded way of trying to answer your question.
Sorry.
Let me go to.
No worries.
Genetic philanthropy. I love how you keep changing your name. Nessa, go for it.
Yeah, sure. My question was about the exactly what was also the difference, the cutoff between for example, what's the difference between detrimental and effectively neutral? If I were to guess, I think if deleterious means there is a zero probability that an allele gets fixed. But neutral means there's a 50-50 chance it gets fixed. But then the cutoff between deleterious and effectively neutral would be 25%, or
it's more complex than that. So if you're thinking about an effectively neutral mutation, let's talk about a deleterious mutation first. A deleterious mutation means that its allele frequency change on a generation by generation basis is determined by selection. So selection is going to drive it to extinction. That's a deleterious allele.
There's a 100% chance that it is lost.
It's not. Yeah, right. Exactly. So an effectively neutral allele on a generation by generation basis is mostly determined by drift. So if you look at the variance is actually higher than the selection coefficient, is the way to sort of think about it. So it's going to jump around. But the key thing is that if you step back and you average that distribution over time, its net probability of fixation is far lower than a truly neutral mutation, right? Even though on a generation basis, it bounces around and it's hard to predict where it's going to go, drift is determining it. As I showed Paul at the beginning, sort of distributions, only from stepping back can you see that actually most of them are going to get driven to extinction. Selection is basically
a scale
distribution.
Is it a difference in scale? On the short term, it just bounces around, but on the long term, it gets most likely to be lost by selection.
Exactly. Yeah. And the same thing is true for an effectively neutral beneficial mutation. If you look at it generation by generation, it bounces around randomly. But if you step back, you see it bounces around randomly in the direction of fixation.
Yeah. Yeah.
So that also a very implication. Like basically, it means that the longer a allele is able to stick around in the population, the more effective it is to be selected or to be influenced by selection.
Yes. In fact, selection is strongest when alleles are at intermediate frequency. So, and it's weakest when they are at low frequency. So, selection, if the allele can manage to get above low frequency and it's beneficial, it will almost always go to fixation, right? It's the early stages when it's most likely to get lost.
Yeah, this is. I wanna highlight that for just a second, because this is another thing that I do in class, and it's really cool, and it blows my students' minds. We look at dominant, recessive, and additive alleles with neutral, beneficial, and deleterious selection coefficients, and seeing how it creeps along at very low frequency, and then as soon as it hits some threshold, it just zoom, and it hits fixation. And you can futz around with where that threshold is based on the effective population size, but as soon as it hits some threshold, it just zoom, it's good. It's so cool, and it's counterintuitive until you actually sit down and do it for the different kind of types of alleles, and that's one of my favorite days of class. Yeah, and it's one of my favorite days of class, because coming into the class, the students really have only been exposed to like Mendelian genetics, where you have phenotype, you have underlying alleles, and it's, as Zach has been saying, it's a 1-to-1, and that doesn't really reflect reality for the vast majority of phenotypes. So after we do quantitative genetics, we can then step back and say, okay, now let's look at how selection works on these more complicated situations. And it's a little bit counterintuitive the first time you look at it. You have to really sit down and work through it. And then you kind of play around with it and you see how those graphs change shape. It's really cool. And then it clicks. And it's beautiful because, and this kind of gets at like the frustrating aspect of having this conversation with creationists. I do this every year with undergraduates, and I see the light bulbs go on. Right after we do Mendelian genetics and quantitative genetics, and we talk about selection and drift and all these things, and then we talk about how, okay, let's look at a quantitative trait, let's look at additive, effects, and you have a beneficial allele with this whatever, and you go through, and all of a sudden it just zoom, and it reaches fixation, and they go, why did that happen? Why wasn't it? And then we break. It's so cool. And then I watch a conversation like this, and I go, why can't you just get it, creationists? Why can't you just see how that works? And it's very frustrating.
Yeah, I like to do the same thing, but with inbreeding. So if you try to say, why does a recessive allele in an infinite population never actually go to fixation, right? Because eventually what's going to happen is that, or why does a dominant allele never actually go to fixation?
It doesn't, right, because
it's because the recessive allele is hidden in the heterozygotes. But if you include inbreeding, suddenly it goes to fixation. And so I make them like figure out why it is that under inbreeding, it will go to fixation. And which is a fun sort of exercise of thinking about what is the average effect of inbreeding, right? And how does that affect selection?
That is almost not word for word, but conceptually, that is literally an exam question I used a couple years ago.
It's such a good question. It like makes them have to synthesize information.
I showed the graph. I showed Zach. I don't know if anyone else watching, anyone else in the room is going to appreciate this, but I showed a graph on the exam of a recessive allele, a dominant allele, and an additive allele, and the trajectory towards fixation. And the dominant allele never hits fixation.
Yeah,
and I was like, explain. And the whole question was just explain this graph.
Yep.
And it was
it's the ratio of heterozygotes to homozygous recessive, and
it's so good.
It will go on for infinity.
It's so good, and it was like
if you can drift to finally make it fit.
And it doesn't take long. It takes a paragraph. If you know it, it takes a paragraph to explain, and you're good. And if you don't know it, you can spend a page, and it will just nothing. Yeah. That's so funny that that's almost exactly an exam question I used a couple years ago. Yeah. So
it's such a good question. It makes them like think through the logic of pop gen, right?
Right.
All right, we're nerding out.
Eli, I know. That's what we're here for. Eli, go ahead. Join the fun.
You guys won't stop, man. I've been sitting here listening and it's circles. No, I'm kidding. Just to ask you this question. I've seen those debates on that channel, and I like them. It's interesting, and I enjoy them. Um, but I've seen the debate about creationist versus what you call genetics, and so my question is this: did he mention, because I didn't get this, that as time moves forward, as generations accumulate, is he saying that there will be a terminal event where it's just total collapse of a species? Because if that's true,
Yeah.
well, okay, I don't believe that, by the way, let me just say, but at all, right? I'm saying it publicly and whatnot. I mean, who knows, maybe some sort of space, I don't know, whatever. But the point is this: there should be then, since that's the claim, there should be a model and a sort of window range in which that all accumulates, and then bam, the end.
There should be,
But if there's not,
but it doesn't.
right? Well, this is what I'm saying. That if there's not, well, number one, what you've been doing, you guys have been doing, not fully, but like with the mice, you're looking back, and everybody's looking back, and back is just that's the evidence there. We can draw the data, but looking forward, the predictive, they should have one that says, hey, by the
They
year.
should.
Okay, that's my question. What do you guys think about
They
that?
should.
Yeah.
No, but this, I think Ration Extrema gets at it here. Okay, but have you considered testing your model against reality will show it's wrong? Like, that's the creationist problem, is that you can put their models against reality and they don't match reality. Like, that's the issue. So you have to have a model that is, as a creationist, you have to have a model that is sufficiently non-specific that it is robust to reality, right? Where, and even if it is just the most ad hoc nonsense, it still needs to be robust against reality. You think about, Zach, you'll know the phrase mutational robustness. Creationist theories have high robustness, right? They are robust against contrary data.
Yeah.
Yeah.
I have a model, a theory model, and perspective that allows for everybody to be happy at the exact same specific time, and it's simple, and it's at the same time, because
Is it
it's
pot?
simple.
Is the answer pot? Is it pot? I bet that would make us all happy at the same
I think that that's
That would-
I think that that's unfortunate,
We'll probably
because I think that I've been rational, and I think that I can I can I think it's unfortunate, but yeah, joking wise, that's funny, but I'm not joking, and excluding the ideas, right, and minimizing people's ideas is problematic, because in fact, what's the point, if you think about it, of even having a debate? Not hear me with you, because I'm agreeing with you guys, but the moment I introduce something that strays from the projected, the acceptable sort of framework, it seems a little bit more like peer pressure. Well, don't go there, and this is not the way. This is just my personal observation of this. This is what the other side does. So it's a human tendency, and that's my point that I was trying to bring up. Human beings are social creatures. Is that radical? No, I don't think so. Is it your domain necessarily? No, I don't think so. But you're still human. So what I'm trying to get at is, even although that's all fluff, it's not the genetic data. I've been talking genetic data as well from a layman's perspective. That should be, at least minimally, not respectable, but at least give the guy at least a little leeway. So what I wanted to say was that the way we make everybody happy is accepting reality as it is. You have a model and you have a domain. There's no reality in which people aren't going to believe in whatever they believe in, and there's no reality in which your domain is going to be fully accepted by every creationist, and or vice versa. People will be
Yes.
poets and people will be scientists, and sometimes they'll be both. So what's the darn point?
The
You know,
darn point. The darn point. Here's the point, and I wanna pull it up from from one of our commenters. Not you. This is. I want to be clear, Eloy. This is not referring to you. This is
I'm
referring.
not getting
This
offended.
is.
I'm
No,
not
no,
getting, no. But I want to make it clear. I am not by any. I am just stating the obvious and pointing out where people lack.
This is.
And
This
I'm
comment was an hour ago, and it was referring to Paul Price during the debate at the end when he's like, scientists are hiding the truth, and they know they don't have mechanisms. He went into conspiracy mode. And that is the answer to the why question. At least it is for me, right? That is the answer to the why question. Because, again, it's not about the science. It's about the foundation of where they're coming from, which is white Christian nationalism to undermine a pluralistic liberal society, right? And part of that is manipulating and controlling the information environment
I agree with you.
to establish an alternate reality where, like, trans people are the threat to everyone, but the rich people literally, like, robbing your tax dollars and putting them in your pocket are, you know, business leaders or whatever nonsense they're coming up with,
Or
right?
geniuses.
It's right.
Can I
It's like
correct-
that's the like that is why, for what it's worth, that is why I do what I do.
Can I
Is
direct
because
Because I agree with you like
Like-
89%.
yeah, like creationism is a gateway drug into all this other nonsense. And a great example of this was during COVID, when many of you watching may remember when Dr.
yeah.
Rob Carter and Dr. Jonathan Sarfati from Creation Ministries International had the gall to put out a video promoting the COVID vaccine so that we could move on from the pandemic as a society. And the responses were almost uniformly not just negative, but like conspiracy theory anti-vax craziness.
Well,
like
it did.
COVID
The
is a
levels
hoax
in our faces.
craziness.
Let me answer
And-
points.
And the two of them, God bless them, in the comments, I remember I have like a million screenshots of a Facebook thread where it was Carter and Sarfati arguing with their own audience, trying to explain to them that viruses are real, that COVID is real, that it's not made up, that vaccines work. And their audience was just like, I'm really disappointed in you. I'm really disappointed that you're just, you know, parroting what the scientific establishment says. And they were shocked at the response they got. And my response to that was, gentlemen, you have spent your careers telling people that scientists are either incompetent or lying to you. What did you expect to happen here?
Well,
Right.
let me answer to all that.
Just can't pick and choose the science there.
Yeah, exactly. You can't put the horse back in the barn, right?
Let me just answer to because I that was good. So I agree with 89% of what you said. There's a little leeway in that, and the only leeway I'll just mention the leeway that I don't particularly align with you on, if I may, and that little chunk is the following: the category of Christian, the category of creationists are placeholders for a slew of people that have different concepts in their minds, in their models. And so there's more of a gradient, the same type of gradient that we see in genetics, where things interplay with each other. Everything has this nature. Everything has this nature, including the macro level of human beings interacting and the micro level as well. So we have dynamic. So
I do want to acknowledge that there are, when I talk about creationists as a subset and part of the project of white Christian nationalism, I am specifically referring to the professional creationists, the creationists that make it their business to promote, you know, Answers in Genesis and ICR and CMI and Discovery Institute, right? That's who I'm talking about when I say, you know,
People are actually
creationists.
making the political decisions right now.
Right, they're the right. Now you've got you also have your rubes essentially, right? You've got your people who bought the propaganda and believed it and are now doing their own thing where they're basically freelance propagandists on behalf of the white Christian nationalists. And I think those people don't have the same level of, ill intent. But in effect, the effect of their work is to contribute to the same political project, right?
They might be getting to the root of the problem anyway.
This is a very American. I'm American, but this is a very American.
Yes. It's very
situation.
American-centric framing.
Yeah,
yes.
We're talking about, because the world is much bigger than the country in which we're from. But now, and I'm not saying that you obviously you would know this and not, but I'm saying that there's perspectives galore. But I want to talk about this.
And a lot of them are wrong. And to be clear, a lot of them are wrong. And I'm running out of patience for the ones that are wrong and like run the country.
Let me touch on that Christian nationalist bit and the white nationalist thing. You gentlemen work with genetics. Isn't it that the Human Genome Project and just genetics thereafter and even before in the 80s, but isn't it something that's well known that this concept of race and whatnot is something that is kind of sort of out of bounds, scientifically speaking?
Yeah, somebody has a fantastic video on that has a lot of views, not as many as it should have, but the comments are hilarious because every now and then it makes its rounds through the race realist circles.
Dude,
let me attach the second.
Hang on, let me go to Zach on this one because
attach the second. I know that you're the feature here, but let me just attach so that I don't forget. If forgive me, seriously, but let me just say
this right here. They're not just wrong, but they're hurting people. That. Yeah.
Okay, so if this is a genetic fact that it's not just one person in one lab or in their office at a computer, but it's like across the world understood because the data is the data. And yet we have on the other end people that are not aware or avoid the data. Attach it to this sort of political, social, cultural bit where they have this specific, racial identity and they dominate and whatnot. If that all those dynamics are at play here, there's really, and I'm not suggesting this about the person that you were debating I'm just saying.
No, you should totally, to be clear, Paul Price is an absolute lunatic conspiracy theorist. I want to be clear about that. His podcast is the most unhinged thing I've ever listened to in my life. And one of my friends makes it a hobby to listen to it and kind
podcast?
of keep us,
Is he a masochist?
Folks, you should.
Well, just the last.
I feel like you can
I just want to, and Paul, if you happen to watch this, I just want to be clear. I respect the work you put into the debate with Zach, but speaking directly to Paul, you are a lunatic conspiracy theorist and you need help, sir. Like, you are completely off your rocker, like, to be clear.
So I just want to I'll end this thing, and thank you for giving me the opportunity. If the use of genetics from the perspective of bypassing the details in order to use fragments of genetics in your social, cultural, political, spiritual, all these, to insert that and to dominate or to crush or to cancel out, then you have created, you're operating in bad faith, in poor faith.
I want to cancel the race realists. I want to cancel the race realists. Does that mean I don't think I'm operating in bad faith? I think they're awful people and they deserve to be canceled. And I think we should cancel the race realists.
Yeah, but we do have freedom of like.
But they don't get to like run society. Screw them. They should be excluded from polite society because they're awful people who are not just like saying things that are contrary to science, but they're saying things that are contrary to science on purpose that they know are lies in order to hurt people and advance themselves.
Well, I can't argue with you on that.
Like, Zach, I want to hear your thoughts on your delightful video that I love to send to people whenever it comes up, which is depressingly often on race realism and how races are fake, and how every now and then apparently it makes its way around the right-wing circles, and that happens because you get a bunch of comments on it.
Dude. So, you know, if you're ever just bored one day and you have nothing better to do, read the comments on that video.
There's like 1,000 of them.
There's been moments in time where I'm like, do I turn the comments off on this?
Nope.
But you know, I've never turned the comments off on any video. I'm not gonna start now. And there's like maybe one of these days I'll make a whole video where I just like read some of the comments. They are some of the most vile and offensive things I've ever seen. I actually ended up having to give someone mod privileges on that video, and they're like, their hobby is to like fight race realist online, which like kudos to them.
Look, if that's the thing that you have chosen to do, then God bless you.
It is like that's what they do, and they apparently go around to all race realist videos and fight people in the comments section.
Awesome.
And this person spends their time fighting them, and I just like gave them mod privileges. I was like, look, if they say something crazy, remove them. So like they just do that now, and they have kind of like curated it. And occasionally they'll send me an email and they'll be like, is this too far? I'll be like, yes, delete that. You know, so
because my standard is I don't have anybody like that. I mean, there are plenty of mods on my channel, and you know. And my standard is, if you have to ask, the answer is yes.
The answer is get rid of it.
Right. If you look at it and go, is that over the line? The answer is yes. It's over the line. Can
I tell you about my experience, one of my first time experience with online race realist? It was I think it was like in 2017. I don't know if you're familiar with this person. It is Steve McRae. Maybe you're familiar with him.
Are we familiar, my friend?
Yeah. Well, to be fair, it is not about him specifically. Like way back then, I joined. No. I like way back then.
He's just super anti-trans.
And now, right. Yes, but way back then, I joined his G plus community way back then. And I made one post on the G plus community explaining how there's one scientific paper that does the calculations. It calculates how long ago the last universal common ancestor was of humans, basically, or when or at what point is everybody alive, the ancestor of everybody alive today.
Identical
identical ancestor points, and it explains that it's about 4,000 years ago, 5,000 years ago, when everybody alive during 5,000 years ago was the ancestors of everybody alive today. So basically, we are all very, very close related, more close than we could think.
A creationist is going to clip those 30 seconds and be like, "Aha."
Right. But it basically means that you have ancestors that lived in the Andes, and you also have ancestors that lived in the south point of Africa. You have ancestors living all over the world.
It's important to note that those are pedigree ancestors and not genetic.
Right. Like I did not make any claims about genetics. I just explained that we all have ancestors living all over the world. But race realists were really mad at me explaining these pedigree things, and that's how I how I got that.
I want to just pull up a couple comments here. So first of all, we get a super chat from Sydney Raptor for $2 dues, as we say. Can we get a biologist definition of succinct? The answer is Sydney. I gave you my reaction in chat. Thank you for your comment. We also have, this is, I think, instructive. Bad faith only applies to members of society, not enemy combatants. Yes, exactly. So, there is a case to be made that I have heard made that I'm, for now, going to remain publicly agnostic on, that it is impossible to engage in bad faith with, like, for example, a race realist. And you know what? Yeah, screw them. There's no like, you could, whatever. Screw them.
Yeah, this gets into like the paradox of tolerance stuff.
Right, exactly. Well, that was another comment. Where it was, where is it? It's somewhere in here. There was a paradox of tolerance comment that, yes, exactly. That's exactly what it is. It's the problem. And the answer is this. Are they the baddies? Yes. And we should treat them like the baddies because they're people trying to ruin things for everybody. And then I just want to highlight, accept themselves. And then I want to highlight this one from Pixie Purple. Dan is too tolerant of dumb people in chat in my humble opinion. Fair enough. But he draws the line at bigots, and I approve of that. Yes, you can spout off whatever stupid nonsense you want to in my chat and in my comments, but as soon as you drop some race realism or some anti-trans nonsense or whatever, you are getting a permaban, you are not getting warned, your comments are just vanishing forever, and no one will ever hear from them again anywhere on my channel. And that's how it works, as God intended.
Let me add this genetic from the layman's side point of view. Ridiculous, I know, but just the same, I have a brain and I kind of use it sometimes. Not to minimize myself, but so I am paternally R1B, right?
Right. Okay.
U152, which for those looking, they can look and see what that means. I am maternally H4. For those looking, it means what it means. They all go back haplogroup wise, not just autosomally, but haplogroup wise. They converge back in time. This is the standard understanding, not in one lab or another, but worldwide. But now the specifics of that is that paternally, I am European. Maternally, interestingly enough, it happens to be that I am Jewish. But Jewish and European are labels that at a given point, based on geography, faith, culture, and all these things, we attach definitional placeholders for to sort of have containers for. But if you look at the genetics without the labels, you need to create labels in order to do the data justice so that other people can understand anything at all.
And the labels can reflect biological reality, which is why races are fake.
And
Zach, and I'm gonna trigger Zach right here. And so are species.
I was going to say one thing. Now I'm going to say two things.
Now we're going to say two things because that is a thing that there needs to be a science friends like 3-on-3 tag team throwdown about whether species are real. It's going to be amazing.
Sorry, forget
Zach, go ahead.
Sort of an important thing here is that by attaching labels to things and saying European or Jewish or this or that, you're actually obscuring the underlying continuous distribution of human ancestry. Human ancestry is not actually falls into categories. It's a
continuous distribution, all living things, and yet we artificially try to put them in boxes called.
I see what you're saying. You guys are saying that I'm saying that because I was agreeing with that. That's the point I was making.
Yeah.
You understand? Yeah.
No, I agree. I'm just clarifying the point.
Yeah.
And so the idea
also good to mention that haplogroups only apply to like the mitochondrial DNA and the Y chromosome. It doesn't apply to autosomal DNA, which is the majority.
And it's fun to remind creationists of that fact because then you ask them what the time to most recent common ancestor for like the hemoglobin gene is, and it's like millions of years.
Yeah. Which one? Which one?
I forget which one. I forget which one.
So like the alpha, I don't remember how long ago the alpha and the beta diverged from each other.
It was a long time ago. It was a long time ago. It was like
didn't alpha and beta duplicated like in the vertebrate ancestor?
Yeah.
Yeah.
So again, importantly, within populations, when you think like within species, then often what you find is continuous distributions of sort of ancestry. And I tried to make this argument within the video that we actually have ways of distinguishing discrete versus continuous variation.
Yeah.
That if it were true that races were real within humans, then we have statistical tests that could distinguish that. It turns out they all fail because the distribution is actually continuous. Unlike the species, when you compare those two things, we actually do have a distribution.
All right. Well played, sir. Well played. And that's it for tonight. Zach has to go real fast, everybody. That's thanks for coming. No, I'm just kidding. That's
But that is where
I want to say. Well, I just want to say, well played, sir.
Right?
Well played.
But that's the most and the race.
Species realism. Sounds like a job for Debate Hub.
We
There
talked
go.
about this, right? Didn't we talk about this in the Science Friend chat?
So there are a couple
Realism
things
debate?
in the Science Friends chat, which for people who don't know, there's a group chat of the Science Friends, and there's a bunch of things that we all agree on, and there's a few things that we've decided we're not going to talk about, and whether species are real is one of them, because
Yeah.
there's a really solid bifurcation in the Science Friends about whether
Wait,
species
I
are
think
real.
I'm the only one, though, right? Am I the only?
Maybe you might be, but that's a lot of weight. That's you.
It is a lot of weight.
You're punching
I feel
above
like
your weight on that
every
one.
single
so.
time I mention species, it's like everyone descends upon me. I'm like, eh.
But at the same time, the rest of us are sitting here going, well, if kinds are at the species level, so I mean, it's we're it's one of those. I look at
my
species-
difficulty.
Go ahead.
Oh, sorry for interrupting. I did not mean to interrupt.
No, you're good. We're online. It's hard.
All right. Like my main difficulty in thinking that species are real is like the concept of species. Like when you think about E. coli as a species, it is very different from when you think of humans as a species. The concepts do not neatly align in both cases.
Don't even.
So in
Now is not the time to do like the 35 species concepts. We're not going to do it here.
I'll just say briefly, I'm not going to go into species concepts. I'll just say briefly that it actually is irrelevant whether or not you can define species in E. coli, because it's actually completely possible that some species, that like bacteria, don't have species because they can freely interbreed with each other. But that's not true of vertebrates.
That's not true for vertebrates.
If you take a peregrine falcon and you take a nuthatch, those two things
those are different species, right?
Will breed with one another. Those are different, and we need a word to define what that means.
Oh, I know a word that's bigger than species, because species boundaries are amorphous,
and
right?
They must be.
And there's gradients, there's continuums of gene flow, right?
And
I propose Zach and Nestlig and Andrew and Eloy. I don't know if you'll appreciate this as much, but I propose the word kinds.
Oh.
You're welcome.
But what
You're
about
welcome.
paddlefish and sturgeons?
I'm just.
We don't talk about that.
Dr. Dan, what you just did is you highlighted the definition. Obviously, you know this because you're the one that performed this. You highlighted the issue at hand. It's the issue at hand because and we've been, and it's what was happening in the actual debate, and it's what's been going on here in the discussion after show, is that people are exchanging definitions and sort of working it out as they go. This is the communication phase, but again, there's this data that's staring in the face. So I just want to throw a wrench in everything, and this is going to go overboard by a lot. And this is the big aha. Not really, it really isn't at all. But some people will go in that route according to their models, the way they see life, and the way they interpret. But if we take all definitions off the table, language off the table, the knowledge of genetics beforehand when people didn't know genetics, and you just strip everything back to, I don't know, let's just say Otzi found in the, I think it was the Swiss slopes during the I think it was the early Bronze Age, or maybe even before. Anyways, Otzi found there an arrow through his back. That person had none of these concepts that we've built to this day right now. Now, this may be something that people could hand wave off, but this is important, at least to me.
Sorry, that was the wrong thing.
Is that we build the definitions. We build the study across time. I'm not a scientist. You gentlemen are. You gentlemen have studied this, and you have your rule sets within your domain, and you do this rigorously. But how about me, that I'm not a scientist? Do I accept, or do I study? Do I decide? Do I opine? What do I do as a typical dude out in the world, and you guys holding all this knowledge? Do I incorporate it into my, what do I do?
I think importantly, we have to bring the knowledge to the world, right? Like our job is to bring that knowledge to you. And if we like circle back to like what species are and how we think about species, we have to let you know this is what we mean when we talk about it, right? And this is the debate. This is why we discuss whether species are real and how we mean by that. And so if we present that information to you, then you can basically figure it out for yourself, right?
Okay. Yeah, and I agree with that. I think that that's the whole point. I agree with it. But what you should not do, in my opinion only, you are free to do as you choose. What we should not do, and not you specifically, I'm just saying people that have access, when it comes to groups that believe certain things, and then you enter debates with them, you already are entering knowing, according to the data, that they're totally off from the beginning, and that the only issue, or at least primary, is that they do not accept in their models what you're offering. They only bucket what they like. So how are you going to come across or cross the finish line to get them to understand when they don't want?
We're not. Like, straight up, we're not. When I can't speak for anybody else, Zach, Andrew, whoever, but when I'm debating a creationist, the last thing I'm trying to do is convince them that I'm right. Because if a creationist is motivated enough to debate an evolutionary biologist on the internet, they are not going to be receptive to anything I am saying. My goal, straight up, is to show the audience that I'm right and they're wrong. But the opponent in the debate is at the bottom of my list of intended audiences for the arguments I'm making.
Yeah, I'll agree. That's definitely my way of approaching it. Is I have I'm under no illusion that I'm going to convince Paul Price.
He's never
going to change his mind. The only thing that I can hope to do is present to the audience something new, something interesting, something they can learn about, something about evolutionary theory they've never heard before. Like, that's my approach, is always to try to be an educator, to try to teach. And that's my instinct. That's what I like to do. And I like to talk about evolutionary theory. And sometimes the best way to reach people is doing like creation v evolution stuff, because they're drawn to it. And then maybe they can learn a little evolutionary theory.
And then you accidentally get like a half-hour population genetics lesson from an evolutionary biologist who does this for a living, right?
Exactly.
And that's awesome. And I literally had that thought during the debate tonight of like, this is just a fantastic, SparkNotes PopGen lesson. Like, this is great. And anybody who's actually receptive to what Zach is saying is going to come away from this with a better understanding of how stuff works, how populations change, how evolution happens, and how we know that that's the case. Now, there's going to be hardcore members of the audience who are, creationists who are not receptive to that. And that's just something you have to accept. Right? And
I will say there are a few members in the audience sometimes who are willing to have a good faith discussion, I think.
Yeah, they are few and far between, I will say, but they do exist. And it's the people, because there's also people who are like already understand the science and accept the science, and it's like, great, you're on my side, go forth and, promote, right? But there's that narrow slice that's on the fence that are gettable. That's the target audience.
I think that's justified, what you guys have said. I think it's totally justified, and you don't need me to say that. I think it's totally reasonable and beneficial. Do you think, all of you, do you think that, I know the answer to this already, according to myself, but I'll ask, is there logical room for a person to both hold a historical, religious, fervent position, or what do you call it, concept or belief or whatnot, and right next to it, on par within its domain, in other words, imagine slicing off, imagine a library, and you as a human being, you have a library, and in your books you have one for science, one for, is that justifiable? And if not, if it is, to what extent, and if it isn't, to what extent? That's my question.
Yeah, I think that this is actually been really marvelously answered by Stephen Jay Gould, of all people, who once called this non-overlapping magisteria, right? That the way in which you approach the world via faith and religion is a different way of seeking truth and seeking understanding versus science. And you can accept under your religious perspective, this is the explanation for the world, and you can accept under the scientific perspective, this is the explanation for the world, and you can hold those two ideas in your head. I think that's possible. I think people can hold those two ideas in their head.
Yeah,
now maybe they
so.
have to make a decision about which one they think is right, and maybe they don't. I don't know. I don't have that conundrum, but I do think it's possible to see both of those things as differential truth statements based on how you got to that truth, if that makes sense.
That is a justifiable, in my judgment, and correct, arrival at an answer. I agree with that. For Dan,
I'm also cool with that until they start trying to impose the one on the rest of us.
That's what has to be separate. Yeah.
Like, you need to keep it separate. I don't care unless you start trying to make me play by your rules that are made up and I don't accept
personal beliefs stay personal.
This is where we end up with in the American terms of our current situation, where we end up with so as a society, and forgive me but let me just say, as a society, we, not us, but the ones before us, created laws and constraints in which human beings within that society could practice or could not, or could do as they so pleased to the without infringing upon others.
Yeah, that would be nice, but that's not the reality we live in. We live in a reality where some fraction of society just lives to infringe upon the rest of us. And it makes me very angry. And that is part of my motivation, most of my motivation for doing what I do on the internet. I do want to start to wrap this up because we have been going for approximately 2 hours, and especially Zach, you have had quite the night. So what I'm going to do is I am going to I'm gonna call this. I just want to check with the folks here. Anybody have anything on YouTube coming up that you are doing soon that you want to promote before we get out of this? Let me just get Eloy. Do you have a channel? Anything that you do?
I have a channel. Okay.
If you want to link it in the private chat, I can put it in the description after.
I have a book, and it's called "How to Invade." Wait, hold on. How to invade a biologist's space and mess up their whole night. No, I'm kidding.
Put the links in the private chat, and I can put stuff for yes.
Well, I have a book. It's on physics. It's on foundations, physics, and phenomenology. Okay.
Okay.
It covers the span of that. It's a 500 plus page book. And you can look it up. Universal principle of collapse, and it covers that space. But I'm not here to promote that. You asked, so I said.
No, all good. I wasn't laughing at you as I said that. I was laughing at this comment from a user who has a rude name. It's kind of funny. And also he was rude to me at the beginning, but then he is fine. I'm promoting a crypto pump and dump join us to the moon, which, folks, crypto is a scam. Don't do it. Just want to put that out there.
I agree with that too.
Is a scam.
Is that a nightjar and a sombrero?
I just want to say thank you to all of you.
Thanks for being here.
I want to thank Dan. I want to thank Zach. I want to thank Andrew, the gentleman that was here before. The Nephilim gentleman.
Oh my god. Okay, so before we go any further, I just need to appreciate the brilliance of Nestlig's new username, because if you know the lore from Nephilim Free, that is way funnier. Please tell me you know the lore. If you don't know the lore, was an incident.
There's some space people that came down and populated the earth.
Well, no, there's a user on YouTube, a creationist, whose username is Nephilim Free, and there was a live stream. I believe it was a live stream where he may have consumed a sheet of paper at one point. So,
gentlemen,
yeah, I need to redo my homework.
That's very funny. That's very funny. Andrew or Nestlig, you have anything you wanna shout out?
I do most of my work on Jackson Beats channel, and so we also finished a script for a new episode on the ancestors tale, so it will be out very soon, I think.
Yes.
It will be on the bladder words tale.
Nice.
The chapter that we are going to cover.
Very cool.
And I also did a series on photosynthesis, so explaining how photosynthesis works and how it evolved. Also a good
Love it.
thing to do.
One of my favorite things to teach is photosynthesis, because it's a beautiful story. You put photosynthesis and respiration side by side, and it's this beautiful. It's like electrons and oxygen and carbon. They're characters, and you have to.
My students hate it so
Oh, I love it, Zach. I'm not
hate
saying
it
my
so
students like it. I'm saying I love
I
teaching
like it too. I go on the board and I draw it,
and you
all
just draw the whole thing.
I draw the whole thing out,
It's
and I
beautiful.
look out at the crowd, and I'm like going at it, and I look out, and they're like,
I know. It's I know, teaching intro bio is a real trip when you really deeply love everything about biology, because you're like, and your students are like,
it's like you lost me way back there.
I know. It's
You know what I do? I give them basically puzzle pieces of the photosynthesis pathway, and
Oh,
then
I
let
like
them
that.
figure out how it fits together.
I like that.
Maybe that will
That's
work.
good.
Yeah.
That's good. Yeah, nice. And Andrew, you doing any debates or anything coming up? I know Donnie was trying to rope you into a thing on
he was.
like hierarchies and stuff, and I'm like, Donnie, I'm right here. This is my effing thing.
I would prefer if if he would allow you to respond to that one video where he the guest kind of strawmanned your hierarchy argument.
I forget who that was. Was that Cherhadi lately? The recent one?
I don't remember his name, but yeah, it was one of the most recent ones.
If it was recent, it was Dr. Matthew Cherhadi.
It's the one I emailed you, I think.
And he emailed me, and I got back to him, and he is not interested in having a conversation with me. But I invited him. But the answer is no. And now he keeps commenting on my videos, on my Kinds video from like 3 years ago, and I'm just like, if you want to have this conversation, email me, and we'll set it up. But he's just like commenting on this video, and not even in the same thread. It's just like multiple comments, but not in a thread. I'm like,
oh, he actually commented on the video?
he commented on my Kinds video that from like 3 years ago, and this is after a weeks long back and forth via email, and I keep saying to him, like, we can hash this out, because he just does not understand what I'm saying. He just fundamentally does not understand my argument. And I'm like, we could sit. It's another example if I could explain it to you, but I can't understand it for you, basically.
And unfortunately, now half the audience at his channel doesn't understand it either.
Well, he just, I know, he's got a video about Erica, he's got a video about me, and it's just like none of what he says is relevant to any of the things that we're saying. And it's just, I would love to explain it to him.
Yeah.
But
I don't have a channel or any content on it, but if I may say something real quick about what you mentioned about photosynthesis and just the theme there. I used to kind of not be into organic and biochemistry much as well, but after just taking a course on it, I will say that even though the chemistry definitely isn't my particular subject, I will say, but I will say that looking into the pathways, the components of cells, just like some people think, well, what's the use of knowing where this electron goes in this chain and whatnot? And to me,
it's awesome.
It gives a new sense of awe to it, and
yeah,
I find
it's
that
so
beautiful.
cool. It's so cool. And I will just say, one of my favorite things that I do is I can't do this in class, because my classes, when I teach this, are like 450 people. So I can't do it.
Wish I was able to take your classes, to be honest.
That'd be great. You should come take my classes. I don't even know where you are. You should come take my classes.
I could drive out there.
What I do is I have the whole big photosynthesis and then respiration all, so it starts with CO2, and then you get your glucose, and then you go into glycolysis, so you go through everything. And then at the end, I take, you make water as a waste product, and I start at one end of the board, and I do this in my office hours, because I can't do it in my real class, but I always get a lot of people in office hours do this. And I go all the way to the end with the water, and this is the great plot twist. And I go, whoop, I make a big arrow and I go all the way across, like whoop, right over here to the
It's
input.
all connected.
And then you take your oxygen that you get out of photosystem 2, and you go whoop, all the way back over to the other, go whoop, there's your terminal electron acceptor. And everyone in the room, everyone in the room just goes, and it just, it's so much fun to tell that story, and it takes 2 full classes, and when they get it, it's so rewarding. Yeah, it's great.
I think this might be a distinction. So you teach like majors biology, right?
I teach I teach Bio 1 and Bio 2 for every life science major.
Oh, right.
So
yeah. I've been stuck teaching non-majors. They do not care. They
that's so fun though.
Could not care less. I did have a few students, so I always include on the final exam, like, what was your favorite topic?
Yeah, of course.
I did have like 2 students say, I didn't really get light-dependent reactions and like the electron transport chains. They're like, I didn't really get it at first, but then when I thought about it, it was kind of cool. And I was like, yes.
Yeah. I one of my courses is a core course that's designed for non-majors, and I love it. That's my later summer course, and it's so much fun.
Yeah.
It's great because these are people who haven't had anything beyond like 9th grade bio, and it's just like, I'm a business major, I just need 3 credits to graduate, and I'm like, I got you. Let's talk about evolution.
Yeah.
And those are fun because I try to build in like weird stuff into every lecture. Or into every class, and it's not lectures. That one's very discussion based. But if you remember, a few years ago during the summer, I did a series of 3 videos. I did like altruism and cancer and whatever. Well, yeah, it was the virulence, altruism, and cancer, and those were adapted from chapters of the book that I wrote for that class. And so it's like, try to just get these non-science majors to like think about it in different ways, and it's a really fun class. I love the non-major stuff, but it's like the enrollment is like 10, which is very different from 50 or 400.
I have a gigantic class.
Yeah. How many you have? How many?
So usually every semester is like 65.
Giant class. Oh,
look, I'm at a smaller university than yours, okay?
Giant class, 65 people. That's my office hours the day before an exam, Zach.
Look, we are proportionate to the enrollment of our university.
I know. I just 65. I have not come September 950.
Oof.
2 sections split. It's going to be 950, and I can't wait. It's the most fun. All right. We've been going way too long, folks. This has been great. Zach, do you have anything fun coming up that you would like to promote? Which creationist are you going to debate next? Everyone wants to know.
Oh, my goodness. The amount of time that I have. Okay, so I should back up. One thing that you should learn, or one thing you should know about being a professor, is it's an incredible amount of work. Like, I don't know.
It's so much
holy
work.
Crap, it is so much work, especially when you start off and you don't have like lectures and stuff already planned out.
Yeah.
Like, oh my God, you spend so much time putting together lesson plans, and like
it takes forever.
It takes forever. I don't have time for this. And so basically and I've also like largely lost interest in creationists. They never really say anything new or
they haven't said anything new in so long.
And so most of my videos on my channel have not actually been anything about creationism. They've been like promoting or like discussing evolutionary theory and like education and stuff. The next big one that I've been working on for a while now is the one on the review of The Selfish Gene of Richard Dawkins' The Selfish Gene. So this is the 50th year anniversary of The Selfish Gene. And what I want to do is talk about not only the legacy of The Selfish Gene, but the legacy of Richard Dawkins, which has been a wild ride digging through a lot of the history and a lot of like various backstories of him and his involvements. And there's some really interesting things about this guy that I feel like aren't widely known beyond the transphobia stuff. And so it's going to be, I think, a video that will be a mix of science, will be a mix of like evolution education. We'll talk about how the selfish gene has basically held up over the past 50 years. And then we're going to talk about how Richard Dawkins has maybe had a kind of negative impact on evolutionary biology education writ large. Not to give any spoilers, but my intuition is that his influence maybe has been more negative than positive. We'll see.
Yeah. I think given the fact that a lot of his legacy is intertwining atheism with evolution, that is a big problem.
Yeah.
That is a big
Yeah,
problem.
that and then just like the continued political stances that he and a lot of the founders, what are the leaders of the new atheism movement have sort of followed.
They're all it's so bad. It's so bad.
So it's going to be difficult to not just talk about like the rise of new atheism. It's going to be a colossal video.
I want to recommend. Obviously, Zach is linked down in the description. I want to just direct everyone to Zach's channel. It is phenomenal. I love it. And Zach, I want you to know that I recommended your Forgotten Synthesis video to a bunch of my students because the week it came out, something related to it came up in class because one of my students asked a just delightful question. I forget what it was, but we ended up talking about selection differentials and heritability and broad sense and narrow sense heritability. And I was like doing some like simple stuff on the board, showing them how the if you graph it out, it ends up as y equals mx plus b, and what the selection or the response to selection. And they dug it, and I was like, if you enjoyed the last 20 minutes, here's a video you should 100% watch. And I was like, this is my friend Zach. He does this, but more, and like this is a great video. And so I recommended it to a few of my students, and one of them, a couple weeks later, said, I watched your friend's video, and that's how she said, I watched your friend's video. I didn't understand a lot of it, but it was entertaining. And so like, you know what? I got a college freshman in bio to watch that video, which was like pretty deep. That was a solid video. And I loved it. I promoted the heck out of that video.
I really appreciate it. That video has been like on my mind for a long time, or doing something about it has been on my mind for a long time. And I just could not get the script worked out well. And I was like, you know what? To hell with it. I'm just going to record it. I'm just going to sit down. I'm just going to say it. And that's basically it was great.
It was, what I did before I recommended to them, I said, you have to understand, my friend Zach, he does some math on a whiteboard during this video, and a commenter on the video said, everyone deserves to find someone who looks at them the way Dr. Zach looks at equations on a whiteboard.
Yeah.
And that like really, I really felt that.
Yeah. I've been super inspired by how well that video is done.
It was great.
I did not expect it to do as well as it did. And given how well it is done, it's really, inspired me to just like keep doing that kind of thing.
Yeah, so, you should, because it's fantastic. I love them all. So you should keep doing those kinds of videos. Okay. Folks, the debate between Dr. Zach Hancock and Paul Price is linked in the description, as well as Zach's channel, and I'll look at the private chat, and anything else that I have, I will add it to the description. I have stuff coming up. I have ideas. I got stuff that I've recorded, haven't even edited. You'll see me, at the very least, you'll see me next Wednesday. I got a thing. Also, I might do a short one soon, because a month or two ago, I noted someone pointed out to me that Answers Research Journal had 0 papers in 2026, and I think that is still the case. So that kind of makes you wonder. So I might do something on that. All right, that is where we are going to call it. Thanks for being here, everybody. Thank you, Zach. Thank you, Nestlig. Thank you, Andrew. Next debate, Dan versus Zach, Are Species Real? We'll get that one on the docket.
It will be held on Jack Henry's channel.
we'll have I was gonna say we'll have Donnie host,
oh my gosh.
Nope. That's not what we're gonna do. All right, have a good night, everybody. Remember to hit the like button before you go, because there's a whole bunch of people here. I don't know how many likes, but it's probably not that many. So hit the like button. Thanks for being here. I will see you all next week or before. I don't know. I don't have a plan, as usual. Bye.